need to use the Pascal triangle. First, we know that any exponential zero is going to give us 1. So for example, in this, the exponent is 4. So we have to find the root 4. And for the first term, we know that we have 1. So like here, we have 1. In the second term, we know that we have 4. So here is going to be 4. And like that until end at 1, like here.
So for the second part, it asks us what is the Pascal triangle and how is it formed. The Pascal triangle is the easiest way to find an expanded binomial. It is formed, for example, in row 3, you use the number that you had in row 2 and you add the first to the second and you get it by cross way. For example, 1 plus 2, you get a 3, and 2 plus 1, you get another 3. And by rule, you always have 1 in the corners. The number of terms relate to the exponent n. Well, the answer for this is simple. If you have n equal to 3, you will have 4 terms. For example, this is n3, 1, 2, 3, and 4. And also, if you have n equal to 3, the following number after the number 1 will be 3, like in here.
Equation, we have to do the same that we do in the previous one. So, like here, the exponent is 5, so we look at the row 5. So, we have to do the same, like x is 1, 5 is here, and the exponent x will be decreasing the exponent, and the exponent y will be increasing, like here, until the exponent
we need to do right here is to find the 25 term of this form of equation, that it's a really big expansion, as you can see, because we have 25 terms in this equation, so it will be so long. But to explain it, in the formula we have 25 in each term of all the equation, and what we need to do is obtain a matrix that will be this marked by the parentheses. So up in the top we will put 25 always, and in the part of down we need to write 0, 1, 2, 3 until 25. And then we need to write x, like here it says, and we need to write the exponent, like there is 25, but in all the terms in order decretion, that will be x at 25, and then x at 24, 23, 22, until x at the exponent 1. And then we need to, as we have 25 matrix 1, x at 24, for example, multiplied by x minus 2, sorry, it will be multiplied all the time in all our terms. And as you can see, let's have this example. We can have this example. So, well, we need to have, so we say that we have 25 matrix 17 at x at 8 multiplying by minus 2 that comes from here to here, okay? And this will be elevated by an exponent that will be the accretion, that will be 17, 18, 19 until you come to 25. And finally, as you can see, we have, for example, 25 matrix 24 x multiplied by minus 2 at 24, and the last term of our series of our expansion will be 25 matrix 25. You don't use x anymore because here is x at exponent 1, so you don't put it here anymore. And finally we'll have multiplied by minus 2 at 25 exponent, and that's all. And finally I will add to my explanation that this form of equation or this formula comes from the Newton's binomial. In conclusion, the Pascal's triangle will help us when we have a binomial that is elevated to a big exponent. So that will be very difficult to use or to multiply term by term. So that's why we use Pascal's or Newton's theorem, because we can do it so fast and so quickly.